carbon dioxide is one of the main greenhouse gases and one of the major contributors to global warming, with CO2 emissions increasing every year. The impacts of global warming are becoming greater and greater. However, CO2 is responsible for more than just global warming and the greenhouse effect. It is also responsible for ocean acidification. So, what is ocean acidification? Well, ocean acidification is defined as the ongoing decrease in pH of the Earth's oceans, which is caused by the uptake of CO2 from the atmosphere. There are many different ways carbon dioxide is released into the atmosphere, with one of the most common ways being the burning of fossil fuels. When hydrocarbon fuels are burnt, the oxygen from the air reacts with the carbon, producing CO2. CO2 is released from industries such as farming, agriculture, and mining. It is also produced in the cars we drive, forest fires, and volcanoes, as well as our very own steelworks here in Port Kembla. How does atmospheric carbon dioxide cause ocean acidification, you ask? Well, the carbon dioxide from the atmosphere settles in the ocean, reacting with the water to form carbonic acid. This in turn produces bicarbonate ions, hydrogen ions, and carbonate ions, which all cause the ocean water to become more and more acidic. The acid in the water makes life for marine organisms more difficult. It kills off our corals, as well as dissolving the shells and skeleton of plankton. This in turn begins to disrupt the food chain, meaning some sea creatures lose their food supply and even their habitat, making the problem of ocean acidification grow larger and larger.
Well, just like Courtney said before, carbon dioxide, or CO2 for short, settles in the ocean, reacts with the water to form carbonic acid. But what properties of CO2 actually aid with this? Why doesn't normal air just dissolve in water? Well, for starters, air, which is mostly made up of nitrogen and oxygen, has a density of 1.225 kilograms per cubic meter, whereas carbon dioxide has a density of nearly 1.98 kilograms per cubic meter, which is nearly 2/3 heavier than air. This can cause the carbon dioxide to essentially sink towards the ground, meaning it's closer to the ocean. What also makes CO2 a contributor to ocean acidification is its solubility in water. Solubility refers to the tendency of something to dissolve in a solvent, like water, and in the case of CO2, means it dissolves into water and creates those bicarbonate ions, which contribute to the increasing acidity in the ocean. Now, CO2 isn't just a one-party trick kind of gas. It's also one of the major contributors to global warming. Now, CO2 has this really nasty property where it absorbs and radiates out heat, but that's not the issue here, since most gases in the atmosphere do this. The catch is that it does it over time very slowly. Kind of like how your frying pan's still nice and hot after you take it off the stove. Ow! We can start to really see how bad carbon dioxide is for the environment when we look into the ocean and see how all that dissolved CO2 really affects life. The main makeup of a lot of marine life in the ocean is calcium carbonate, which forms things like coral structures, shells for clams, oysters, sea snails, and some plankton. When acid reacts with substances like calcium carbonate, they start to dissolve, and that's exactly what the carbonic acid is doing to the calcium carbonate, causing it to dissolve. This is really bad. If we dissolve away the shells and skeletal structures of animals such as marine life, we're not only putting them at risk, but also ourselves, since more than 1 billion people rely on the ocean as their main source of food. No food means starving people.
Now, not everyone believes that ocean acidification is happening, let alone is a consequence of increased carbon dioxide emissions. As we just learned from Matt, there are some real, tangible environmental consequences which are occurring as a result of man-made industrialist action over the last 150 years. There are some people out there who think that these are simply scare stories, designed only to lead the public into mass hysteria for political agendas. So now, let's look at some examples, shall we? Now, there are people out there like James Delingpole who believe that the phenomenon has been hyped for political, ideological, and financial reason. They believe that there is no evidence for ocean acidification in itself. While Delingpole's paper lacked real scientific evidence and dismissed wider scientific literature, the views which he shares with many are not actually based in fact. Clifford Ollier, an Australian, which is very disappointing, deemed the phenomenon a hoax. There are people out there like Ollier who believe that the heightening acidification of the ocean is actually essential to the survival of the coral reefs. They cite the facts that A, increasing carbon dioxide emissions within a greenhouse increases the crop yields, and B, that animals which secrete carbonate thrive in high carbon dioxide levels. This is not applicable here. These studies are based on high school science and do not encapsulate the actual chemistry and biodiversity present within the oceans. Furthermore, Ollier cited facts such as the ocean recovered when the carbon dioxide levels were 5 times higher in ancient times than what they are now. This is a true fact. However, the rate at which ocean acidification is occurring is the detrimental aspects, as the ecosystems do not have time to adapt to these changes. They do not have time to acclimatize to these increases, and thus they will die. Their facts are completely baseless. Scientists time and time again have proven that CO2 emissions have increased the acidity of the ocean and is thus having a detrimental impact on the rich ecosystems which reside there. Recent studies of coral from the Great Barrier Reef have all but confirmed that the last 60 years of increased anthropogenic carbon dioxide has drastically increased carbon dioxide in the water. Furthermore, an American team recently proved the current effect ocean acidification is having on coral life. It devastates their ability to sexually recruit and will thus inhibit the ability for certain coral species to recover from disturbances such as the warming and increased acidity of the ocean. This is just one of the many studies which have proven that this phenomenon is happening and is deadly, all reproducible and backed by science. I trust the judgment of trained scientists over people who are guessing, to be honest.
The need for action is now. It's alarming to consider the potential impacts ocean acidification can have in biological, ecological, and socio-economic contexts collectively. The current legislation and objectives are still far too problematic in terms of ocean acidification and CO2 production holistically. The best course of action right now? Widespread education. We need people across the globe to acknowledge the effects of ocean acidification and for there to be a unifying attempt to reduce levels predicted in the near future. We also need people to be educated in the ways they can help in their day-to-day lives. Something as simple as using public transport for a few days or limiting electricity use at your home is a small yet effective on a small scale.
Whilst these strategies can be worthwhile, there has to be a bigger onus placed on the big contributors worldwide. Greater taxation and accountability for fossil fuel implications is a huge step in the battle against climate change and inevitably ocean acidification. This would need to be further adhered to in countries and regions that produce larger amounts of CO2 than others, as reducing these places' environmental impact would greater affect the overall production of CO2 into the atmosphere. If countries like China, USA and India could all agree on a climate change strategy, the residual countries would have a greater incentive to change and reflect the powerhouses of the world's economy. On a smaller scale, there could also be a greater push for sustainable fishery practices to reduce overfishing and place less stresses on the marine ecosystems, as such networks that can counteract the effects of ocean acidification.
A less doom and gloom mitigation could be through nature itself. Studies have shown that through the use of seagrasses, kelps and shellbeds could aid in the reduction of ocean acidification in known areas. In fact, these areas could have predicted 18% growth in marine and coral life. Although whilst this could be ideal, it is far too ineffective when up against mass-scale production of CO2 across the globe.
The take-home message from all of this is a hope that you further understand the diverse effects of climate change and the vast implications that variables like ocean acidification can have in the environment around us.
We hope it becomes natural to
Make an ocean, save the ocean!